Hello, welcome back. So in the previous example, I have taken the single angle section. Now here, I will take another example of the angle section, and in this case, you can see it is a discontinuous strut of length 4 meter consists of two unequal angle section. In this case, we are going to find out strength of two unequal angle section, and the size of unequal angle section is 100 by 75 by 8 each, and it is connected to a 10 mm thick gusset plate by its longer leg. So it is actually connected by the longer leg. So in that case, it says determine the strength if it is connected on the opposite side of the gusset plate and on the same side of the gusset plate. So in the previous part, if you remember that I have shown you a diagram in which angle was connected on same side and angle was connected alternatively. I will show you the same diagram again. So here you can see in the angle, in this case, angle is connected along the same face, along the same line. So in that case, two angles are connected along the same face, while in this case, angles are connected on opposite manner. Like one angle is connected on this side, the other angle is connected on this side. So this is a simple concept that I want to show, which we are going to solve. So in our question, two angles are there. So there are two cases. We will see that again. So here it says that if the angles are provided opposite side of the gusset plate, which means, for example, if this is a gusset plate, so one angle is provided on this side and one angle is provided on this side. So this is the one case. Another case, it says in the second problem, it says on the same side of the gusset plate. Like again, if this is the gusset plate, so angle is provided like this, and the another angle may be like this. So it is provided on the same side. So that is the case B, and this is the case A. So it says that we have to find out the strength of this double angle system in this case and in this case. Okay, so again, to find out the compressive strength, same formula we will use, FCD into AE. So all the game is for this FCD, finding the FCD value. So as you can see here, in both the cases, there are three sections actually. One is this gusset plate, and two are the angle system. So again, like we have done in the example 2, there were three sections in the example 2, and in that case we were supposed to find out the radius of gyration of the combined section. So the similar approach we will follow here. So FCD value, again, as I said, it depends on lambda value, and lambda depends on KL, which is effective length, and R, which is radius of gyration. And to calculate the R value, the formula for calculating R is I by A. So in that case, we have to find out I of the combined section. So in that case, combined section would be both angle. So the whole system will be having some R value. So we have to find out that along X axis, along Y axis. So we have to see that accordingly. And once we find out the R value, then we will find out the effective length, and then we will find out the lambda value. And once we find out the lambda value, we can find out FCD value. So the same process that we are following from previous example, the same process we will follow here. The only difference is the type of section here is different. So the approach may be different here. So that is what we have to understand. So we will start our problem here. So first step is about finding the properties of the section. So again, using the steel table, we can find out the properties of the angle section. So I have already explained how to find out the value from the steel table. So you can refer to that. So I'm directly giving you all the values here from the steel table. So from the steel table, we can find out all these values which will be required for us. So in our problem, we will be required A value, Rx, Ru, Cx, Ix, ry, rv, cy. So all these value will be required here in our problem. So that is why I have written all the values here initially. So now we have to find out, uh, first we will use the case 1. So in case 1, when angles are placed on opposite sides of the gusset plate. So I will show you the figure, how it will look like. So in the diagram, you can see the longer leg is connected. So that is why this leg is 75 mm and this one is also 75 mm, and in between there is a uh, gusset plate. So if we look at the whole system CG will be this one. So this CG, sorry, this is the CG for the whole system. Similarly, if we look at the CG of the single angle system, so for this angle system, this CG will be like this here. Similarly, the CG of this angle system will be here. Okay. So the axis along this CG will be this one. So this will be x-axis, and another axis along this CG which will pass. So you can see here, it will pass through the center of the gusset plate. So this is the y-axis and this is the x-axis. So now you can see that CG, x-axis of the whole assembly is passing through the CG of individual angle section of this individual angle section, and also along the combination of the whole section. So you can see all three CG are in the same axis, which is x-axis. Well, what does it mean? It means that the radius of gyration along the x-axis of the whole system and for the individual angle section will be same. So that is the point that I'm trying to make here, that if such condition occur, like the CG of the single angle section and CG of the whole combination, if they lie along a single axis, then radius of gyration about that axis for single section and for the whole assembly will be same. So that is why I am saying that Rxx for the assembly, I am writing here Rx dash, will be equals to the Rx of single angle section. So Rx here given as 31.4 mm. So this Rx 31.4 mm will be same for this single angle section and for the whole assembly. It will be same. So that is the concept. Whenever we find such condition, we can directly write here. We can directly write uh, as we are supposed to find out lambda. So in the lambda, we are supposed to find out R minimum, and R minimum will be the minimum of Rx dash and Ry dash. So Rx dash is the radius of gyration of the whole assembly about the x-axis. Ry dash is the radius of gyration about the, a radius of gyration of the whole assembly along the y-axis. So in the x-axis, it is very easy to find out because all three CG lies along the x-axis. So that is why I have said that Rx dash will be same. So as we can write here, Rx will be same 31.4 mm. It will be same as for the single angle section. Why it is same? I have just explained the reason. Now also, if to find out the R value, we know that I by A is the formula, whole under root I by A. So in that case, we have to find out A also. Well, A is the total area of cross section. So here I am writing A dash. So A dash will be the total cross sectional area of the both angle section. As both angle sections are same, so that is why I have written here angle section 2 multiplied by 1336, which is 2672. So I have just find out this from the steel table. So multiplying by 2, we can find out the total area of cross section of the angle section. Okay. So now we found the value, we found the Rx value also. Again, we have to find out Ry value. Well, Ry value will be different. The process of finding Ry value will be different. Why it is different? I will show you that in the next page. So again, the same diagram, you can see I have explained that the CG of the whole assembly will be at this center, and CG, individual CG of this angle will be here, and CG of this left hand side angle will be approximately here, and all three CG will lie along x axis on the same axis, which is x axis. But in case of individual case, the y-axis, I mean y-axis of individual angle section, like this one. This one is the y-axis for this angle section, and this one is the y-axis for this individual angle section. But if we see the whole assembly, in case of whole assembly, the y-axis will be this one. So you can see all three axes are not coinciding along the same line as they were in case of x-axis. You can see x-axis of individual individual angle section in this case, and in this case, and for the whole case, it was coinciding along the same line. But in case of y-axis, they are not coinciding along the same line. So which means there is some distance. There is some distance between them. And because of that, we have to find out moment of inertia using the parallel axis theorem. So I have already explained the parallel axis theorem in example 2. So you can refer to that. So here I am writing here directly. So in case of parallel axis theorem, as we know that both angles are same size, and also the distance between the main y-axis, this distance and this distance. So both of these distance are same. So that is why I'm multiplying this by 2. So Iyy is the moment of inertia of the whole assembly about y-axis. So we are considering this main y-axis. Sorry. So we are considering this y-axis. So I am writing this as y, and these are the small y. Okay. So about the y-axis, we have to find out that. So for that, we are going to find out moment of inertia of individual angle section. So for the individual angle section, moment of inertia about this axis will be Iy. So we can find out direct value from the steel table. So I have already written in the previous slide, you can see here Iy. So Iy is the moment of inertia of one angle section, which we have found from the steel table. So this is the Iy along along this axis, and A is the total area of cross section of one angle. So here we are, because I have already multiplied by 2, so there is no need to write. This is not actually A dash. A dash was 2 into area of cross section of one angle section. So this was A dash, but A is the area of cross section of one angle section. And Cy, we have already I have already shown you. Cy is basically this distance. So this is the Cy, which is distance between the y-axis, small y-axis, and the extreme left edge of this angle. And also, because we are supposed to find out this distance, so this distance belongs to the center of the gusset plate. So in that case, Cy plus half of the thickness of gusset plate will also be used. So that is why I have written here distance Cy plus Tg by 2. Tg is the thickness of gusset plate. So thickness of gusset plate is also mentioned here. So all the values are written here. I have already explained this in example 2. How do we use parallel axis theorem? So you can refer to that if it is not clear to you. Okay. So now putting all the values 2 into this and this, all the values I have put here, and by calculation we find Iy dash as 276.68 into 10 to the power 4. Now we can find out Ry dash also, and the formula for this under root Iy dash by A dash, and putting the value we get the Ry as 32.18. So now we are supposed to find out R minimum. So R minimum will be the minimum of R x dash and R y dash. So R x dash we have already calculated in the previous slide. You can see here R x dash is 31.4 and R y dash is 32.18. So on very small difference is there, but still we will take R minimum as 31.4 mm. So that is our R minimum. So we have found the value of 30. Radius of gyration, minimum radius of gyration. Now we will find out LE, which is effective length of the angle section. Well, in case of double angle section, how do we find out effective length? That we have to see, and it is being mentioned in the IS code also. So first we will see that IS code clause, and then we will see what will be the effective length. So we will go to this IS code clause number, and there in the IS code it is being mentioned what will be the effective length of double angle section. So I will show you that